There was this one particular time in the Maldives that really stuck with me. So we used to take boat trips to explore the reefs around Lamu Atoll. And on one of these trips, we stumbled upon this absolutely pristine reef called Bagicha.
Yeah, yeah, that was absolutely stunning. And Bagicha actually translated in Devehi means garden, and that's exactly what it felt like. You know, it was such an appropriate name for such an incredibly beautiful place. I think everyone after that day said that that was probably one of the best snorkels they'd ever been on. The coral diversity, the structure of the corals was just magical. I think one of my most memorable sort of images is these table corals that had obviously sort of toppled from their sheer size, but then continued growing out horizontally and then toppled again. And so it made this sort of concertina look like a flowing waterfall, but of this solid coral. And it was just unreal to see. Absolutely stunning.
Yeah, I think it was easily one of the most just kind of perfect coral reefs I've ever seen. I couldn't even see the sand. It was just carpeted with corals.
Yeah.
And, you know, we were first snorkeling on this reef just a couple of months before the mass bleaching event hit the Maldives. So, you know, we hadn't seen the effects of that yet. But in the following months, when we just kept going back, you could slowly start to see the reef transform from this, you know, vibrant, bustling reef to just a field of white. And, you know, that was really, really heartbreaking.
Yeah, yeah. No, I'll never forget that feeling of seeing that change come in each time we went there, and it was getting whiter and whiter, and feeling completely hopeless watching this happen. You
Yeah.
know, both of us were snorkeling around, having to clear our masks because of the tears were literally, catching in our mask. It was definitely one of the most emotional snorkels ever. So hard to watch. But having said that, we also were lucky enough to see reefs elsewhere around Lamu, which also bleached, but actually bounced back really, really well, and actually were recovered. You know, just a year later, were back to full recovery and doing brilliantly. And I think that's one of the most interesting things about corals is this complexity that certain species do well in heat stress and others don't, and they don't cope so well. And this complexity is something we're going to be covering today with our guest.
Absolutely. Welcome back to another episode of Ocean Unpacked, your one-stop shop to get the latest in ocean news and research, along with some amazing facts about life under our seas. This episode, we're going to be talking about corals, specifically what they are, why they're important, and what the future holds for them in a rapidly changing ocean. And joining us to help us unpack these questions is coral expert Dr. Rhiannon Davies.
But before we bring her onto the podcast, let's quickly cover what exactly corals are. Are they an animal, a plant, or just a rock? And it's a little bit more complicated than that. And actually, it's kind of all three in a way. So corals themselves are actually an animal. They have living tissue that grows, they reproduce, but they don't do this on their own, or they can't be successful on their own. Because within the tissue of the live coral is a microscopic photosynthetic algae called zooxanthellae. And this algae, like I said, lives inside of their tissues and photosynthesizes, providing nutrients for the corals, and the corals obviously provide a safe home for the zooxanthellae. And this is what's called a symbiotic relationship, meaning both organisms benefit from this collaboration. So the corals obviously provide a shelter for the algae to live in, and in return, the algae actually provides about 90% of the coral's energy through photosynthesis. So where does that rock part come in? Well, corals actually build a calcium carbonate skeleton underneath their tissue as they grow, which is the hard, stony skeletons that we see when we look at a live coral reef, or in fact, you know, dead coral reefs, or when coral washes up on the beach. What you're seeing is the skeleton of the coral with no living tissue over the top of it.
Yeah, and on the topic of corals, there actually has been some pretty big news making headlines at the end of last year. And it was actually this really, really big report that came out from an organization called Global Tipping Points, led by the University of Exeter, that was essentially saying that coral reefs are one of the first systems in the world to reach their climate tipping points. And it was really, really big news. And for those who don't know what a tipping point is, tipping points are essentially moments when a major ecosystem reaches a point where severe degradation is inevitable and sometimes even potentially irreversible. Now, in the case of coral reefs, this tipping point is reached when global temperatures have increased by 1 to 1.5 degrees above pre industrial levels. So, for context, we are currently sitting at 1.4 degrees above pre industrial levels. So, well within that range for these climate tipping points for coral reefs. Now, this rise in temperature results in greater frequency and intensity of coral bleaching events worldwide, which is one of the major causes of coral dieback in our oceans. So, it is really, really kind of big, significant news for everyone to say that coral reefs really have reached their climate tipping point. But what does it actually mean when we say this? When we say they've reached their climate tipping point, does it spell the end for corals? Can they still bounce back from this? So we're going to be chatting with Rhiannon to help us unpack these questions and learn more about her research on these incredibly important ecosystems. Welcome to the podcast, Rhiannon.
Hi, thank you so much for having me. I'm excited to be here.
It's great to have you on the podcast. We're so excited to hear what you have to say about this topic because it's such an interesting one. It's quite complex, a lot more complex than most people think. So we're really interested to hear what you have to say about it. So Rhiannon, tell us a bit more about yourself and your coral research.
Yeah, sure. So I just finished my PhD, which looked at the past and present of Maldivian coral reefs. So I was really focusing on how coral cover in the Maldives has changed through time, starting from around the 1950s up into more present day, so as in last year, 2025. And then now I work for the Maldives Coral Institute as a postdoctoral researcher. And I'm really helping to lead a project that we are about to initiate this year called the Coral Reef Regeneration Collab. And that really focuses on, well, what it says, like regenerating coral reefs. So rather than just restoring them to a point of where, a coral reef may have lost a certain amount of coral reef, and instead of just trying to restore it back to what it was, we're really trying to reinvigorate the reef, create it a lot more diverse and able to withstand any more future impacts.
That's super cool. Look, I definitely want to hear more about that later on. We need to talk about that because that sounds amazing.
But before we kind of dive into that, why coral reefs? Kind of what drew you to want to study these animals and these systems?
I think they're just so incredibly beautiful. I was really fortunate to grow up in Southeast Asia and Singapore. So I was exposed to coral reefs from a really young age. And I'd like to say that my dad was a really big inspiration into why I do what I do. He got me scuba diving at the age of 10. So he was the first one that chucked me onto a coral reef. And I think seeing them at that age and seeing how magical and incredible they are, full of life, was, it always really stuck with me. And at the time when I was younger, it was all about the fish and the sharks and the things you could see on it. But as I got older, I realized how important coral reefs are. And I think even from a young age, watching nature programs and those sorts of documentaries, the whole idea of coral reefs and how vulnerable they can be to climate change has always sort of been apparent. And learning more about that just made me realize how much I wanted to be involved in helping them and to protect them and keep them around for generations to come.
Yeah, that's amazing. Do you think that exposure at a young age really made a difference in terms of, like, you had that passion? Was that one of your first sort of passions that you wanted to explore?
Yeah, definitely. I think you really love what you see and you want to protect what you can see and what you love and what you're passionate about. And I think the younger you see these things, the more that you feel connected to them. I mean, from sort of around that age of learning how to scuba dive and getting a bit older, from around the age of 12, I always knew I was going to be a marine biologist and nothing was going to change that. So, yeah, I think it was pretty pivotal for me.
Yeah, and I have to say from my side as well, I feel like I didn't have that appreciation of coral reefs till I got to the Maldives, because I think, like what you said, for a lot of people, they're focused a lot more on the kind of big charismatic animals and they don't really see what's underneath them, what they're swimming over. But now I get the hype. After spending a couple of years working in the Maldives and kind of seeing everything we've seen with coral reefs there, they're really, really special.
Yeah, they definitely are. And I think it's so easy to love the big things. And if you're swimming over a coral reef, it's easy to think, oh, it's just dead rocks or it's just substrate. It's just other things grow on it. It's where things live. But without them, you wouldn't have those amazing animals and you wouldn't have these incredible ecosystems. So, yeah, they really underpin a lot of tropical, marine life.
Let's dive into that a bit more. You mentioned how important coral reefs are. What role do they actually play then in that whole marine ecosystem? We know the oceans, this whole podcast is all about the oceans and how important they are. So we know how important the oceans are to the globe, the human population, but what are corals doing for the ocean?
Yeah, they're really, so as I said, they are marine habitats for a lot of species. The estimates now are between 25 and 30% of all marine species live on coral reefs. So they provide food for them, they provide habitats for fish to live in. They're quite structurally complex, so you have a lot of hiding spaces for fish. And then they also are really great for coastal defenses. In the case of the Maldives, they literally created the islands that form the Maldives. They are coral reef generated islands. And then so they protect and create those islands, but then they also protect other coastlines as well. So coral reefs in these tropical areas are the frontline defense against things like rising sea levels and storm surges and waves and hurricanes. So they're really important in that way. They also underpin a lot of livelihoods for coastal communities. They provide the fish that people make money off of and eat and have most of their protein. But tourism is also a really big one. It's a huge industry and coral reefs are really important for that. And then there's lots of small nuances as well, like they're really important for the medical field and those sorts of things. So yeah, very, very important, incredible habitats.
Yeah, very well put. And just kind of circling back on your PhD research, because you were saying you look at changes in coral cover, historical changes in coral cover in the Maldives. So what would a coral reef have looked like, 50, 100, or even 200 years ago? Like, how would they have looked different from how they are today?
Yeah, I think one of the really big obvious ones is that there would just be more of it and it would look a lot healthier. It's hard in recent years to know what some coral cover would look like because we just don't have like the actual analytical data for it. We do know that, anecdotally from people diving and snorkeling on reefs that they were just incredible. We know that they would have had much, much higher coral cover. So around about now, you would say average coral cover globally, I think sits around 25%, whereas you'd be looking more at like 50, 60%. In some areas of reef, it can even be more than 100%, which sounds a bit bizarre. But if you think about what I mentioned before, how structurally complex a reef is, you've got corals on top of each other. So it can just be insane. You're probably looking at much higher diversity of corals as well. The unfortunate thing about some bleaching events is that it can cause certain species to go functionally extinct or, just have a much lower prevalence of them. And some reef systems might not see certain species anymore. So that's really what you would look at, just something a lot more vibrant and complex with a lot more species on it.
And I think there are some reefs, that we've seen that I imagine don't look too different from reefs 50 years to 100 years ago that still have that high coral cover and that high diversity.
Yeah, absolutely. There's definitely pockets of refugia out there where you can really get a glimpse of what these coral reefs would have looked like back then, and without a whole lot of pressure. So.
And obviously, you just finished your PhD, which is amazing, but it is 3 to 4 years of just, I think we all understand that PhDs can be such grueling work and extremely intense, but can you tell us about some moments that have really stuck with you when you were out in the field or even, just behind a computer, doing your research and doing your work for your PhD?
Yeah, the field work definitely was a lot more fun than being stuck behind my computer analysing stuff on RStudio. But Yeah, there is, again, I'm so fortunate to have been able to have, go diving on some of these reefs. And some of the most beautiful reefs I've been on actually were in Lamu Atoll, looking at the size structure of different coral reef communities out there. And yeah, I mean, you would go scuba diving on this reef that would just be incredible, and you didn't think reefs like these existed anymore because the coral cover was so high, the diversity was so high, and then all of a sudden, a manta ray would come across your transect, or there'd be mobulas, or I remember diving with Greg once and there being a whole shoal of grey reef sharks, and he barreled into me underwater, being like, "Look."
Yeah. That was incredible. That was like in the middle of a hunt or something. They just came zooming past. That was super cool. Yeah, I remember seeing you just with your head down in the corals, as everyone knew your dives were like that, just head down in the corals, and I had to physically go and grab you and go, look up, look at all the sharks swimming straight over your head.
Yeah.
Henry's just like, I'm trying to do research, Greg. Stop distracting
me. Well, that was really the main purpose of any of my buddies. One, to keep me safe, make sure everything was all fine. But also their rule was, if you see anything cool, you have to let me know, because my head will be in these corals.
So we've talked a lot. We introduced the episode talking about some of the reefs in Lamu and talking about Begica specifically. And both Julian and I were, fortunate enough to snorkel on a reef like Begica, but unfortunate enough in a way that we saw the bleaching happen over months. We visited numerous times over that high temperature period, and we witnessed the just annihilation, or at least the bleaching of huge amounts of coral. So it's obviously a huge issue. What is making the more recent mass bleaching events more cynical, maybe is not the right word, more dangerous than bleaching events we've had in the past? Because a lot of people might argue, coral reefs have bleached for thousands of years. What's the big deal about them bleaching more recently?
Yes. So, these climate cycles are obviously a normal thing that happens. I think what's so concerning is that it's obviously speeding up and it's becoming, a lot more intense. So bleaching events in the past would be rather sporadic. They wouldn't last as long, or they wouldn't be as intense. There wouldn't be as much heat stress affecting the corals. Whereas now, because we've really increased global ocean temperatures so much that corals are sort of almost always at their thermal threshold in certain areas. And so if you're having regular bleaching events to the severity that some of these are, then you're not giving the corals any chance to recover or recoup. So you had a lot more time between some of the earlier bleaching events, whereas now it's not uncommon to see minor bleaching happen every single year, around those, those summer months when they get really hot for certain areas. So if you're not giving that coral time to recover, then you're just constantly hitting it, and it's only going to further degrade. Equally, even if you're not having those super intense heat stress events, like those mass global coral bleaching events that affect large areas and have high amounts of accumulative heat stress for a particular area, even if you're having just these minor bleaching events, you're still putting coral through stress. And that physiological stress is going to weaken it to things like disease, or just anything like that. It's just going to be a lot more susceptible and more likely to die. So, or if it doesn't immediately die from a minor bleaching event, the biological costs or the physiological costs that it's incurred is going to affect how it reproduces in the future, or it's going to have caused so much damage that it ends up dying anyway, but just a few months later.
Yeah, it's really important to realise that it's that chronic stress that's the problem. We know that in humans, that long-term chronic stress is massively bad for our health, and it's no different for the corals. Only it's just purely due to temperature, right? So when they're sitting at that higher temperature, it's like they are literally in a much higher stress environment. So imagine being in that high stress environment for for years on end and hardly ever getting any sort of respite. It's no surprise that, like you said, they're weaker, they're more susceptible to disease, and then when that temperature spikes at all, it's just, it's enough just to completely knock them out. So it makes a lot of sense that corals are so stressed at the moment.
Yeah, no, I think I fully agree with you there. And there was actually some big news about it, kind of highlighting that at the end of last year, talking about how coral reef systems were essentially one of the first systems to reach a climate tipping point. But obviously, what that actually means is a little bit harder to say, but maybe you can tell us a little bit about that and kind of your understanding of what that means.
Yeah, I think with, the tipping points, it just sort of means that a lot of the coral reefs at the minute have reached that sort of critical, threshold where you're seeing quite devastating and catastrophic impacts from bleaching events. And so there will be certain reefs that have reached that threshold, reached that tipping point, that won't necessarily be able to come back from it anymore. They've just had just been hit so badly and had such high die-offs that what remains isn't going to be able to replenish itself. It isn't going to be able to recover efficiently, and you're going to have species that won't come back because it can't reproduce, or that, if there were a small amount of corals that were left that could be able to, recover and replenish itself if given enough time, it's only going to be hit by another bleaching event the next year, and so that's going to cause it to die off as well. So it is quite concerning that there are reefs that have reached this and they're going to be sort of dramatically altered and are not going to be able to recover. But I think the positive side is that there are still reefs out there, these pockets of refugia, that are able to withstand it and have withstood it so far. And I think, focusing on that is really important, because it isn't all doom and gloom. I mean, there is a lot of media coverage at the minute, and don't get me wrong, we still need to prioritize, working to reduce global greenhouse gases and global emissions. But, coral reefs are, I don't want, they will, I think, in my opinion, coral reefs will still be able to survive. And they might look different to how reefs are now or how reefs were, but, I'm hopeful that we will still have reefs.
Yeah, a lot of us have to be a little bit hopeful. And it's something that I saw as well, during the height of the bleaching in the Maldives in April of 2024, we were running a research expedition around Lamu. And, we were surveying the level of bleaching on some of the reefs. And for most of them, we were seeing 60, 70, 80% bleaching. But then we'd occasionally come across these little pockets of what you said, these pockets of refugia, where, we'd have incredible coral cover with no bleaching whatsoever. And it would only be, a couple of kilometers down from a reef that was almost completely bleached. So I think it is such a complex system. And I think the way you put it, that it's, it's not just that because it's reached a climate tipping point, that means it's it. That's the end for coral reefs. But what are some ways that corals can adapt to these kind of increase in bleaching events and increase in ocean surface temperatures?
There's a lot of research at the minute that's looking at how to kind of help corals adapt. There are lots of different ways. The actual genetic mechanisms and processes that cause corals to adapt to heat stress are less well understood, and there's a lot of research in it at the minute. But corals can adapt through different ways. One of them is, these bleaching events act as natural selection events. So they're wiping out those coral individuals and those coral colonies and species that are more thermally sensitive. And so the ones that survive are the ones that were able to withstand that heat stress. So then they survive and they reproduce, and then they pass on those genes or those traits that are able to help them to withstand these higher temperatures. There's also research around acclimatization, where previous heat stress events can help cause corals to sort of remember that heat stress event and kind of help prime them for future ones. So there's mechanisms through, phenotypic variations that got them there, that helped them survive in the first time. Those are more easily remembered and accessed, so they can start priming themselves before that heat stress gets really bad.
So it's basically like a coral vaccine almost, right? It's sort of the equivalent of what we do with a vaccine. We give a small dose, a controlled dose, so that our body knows how to deal with it. You're saying that for corals we can do the same sort of thing, obviously not necessarily with a disease, but to prepare them for temperature stress?
Yeah, it doesn't work like all the time for every single coral. Like individuals are very specific. There are lots of different things that can help a coral to adapt. But yeah, corals, research now is kind of pointing towards corals having these things called epigenetic memory, which basically can help prime corals and like remember heat stress event in the absence of actual genetic adaptation. So that's really interesting. But other things that can help coral is, again, the type of algae that it harbors. There are some that are more heat tolerant than others, but also the microbiome, so the bacteria that kind of coats the surface of the coral. They're now saying that can have an influence on how susceptible corals could be to heat stress. So yeah, there's lots of different ways that they can adapt and different ways that we can help them.
Yeah, and I think this brings us really nicely onto the project you were talking about in the Maldives, your new project that you're just starting to work on. What was it called again?
The Coral Reef Regeneration Collab.
Amazing, yeah, quite a mouthful. Tell us more about it. Like, what are you doing, and what are you aiming to achieve?
Yeah, so the project basically is kind of a play on words with this collab, because it is like a collab where it's a hub, it's a space for lots of different individuals and organizations and coral reef restorers. They can all come together and they can share ideas about the different kind of techniques that they've used that have helped corals. Sharing what works, what doesn't work, because every reef is really unique and different and will have a different set of problems that it needs to face. And, there's not a one size fits all restoration practice that's going to make corals be restore and be better and thrive again. So it has to be really adaptive, and you have to change it to that area and tackle on the problem that's in that reef. So we're very much in the beginnings of it, but it's looking less on like, oh, this is a degraded reef, we're going to put frames down with fragments and that's how we're going to restore it. But it looks kind of at the bigger picture. So possibly looking at things to remove algae. So algae can really inhibit coral recovery, and especially baby corals as coral recruits, because they'll settle onto a reef substrate, and if there's algae covering it, the algae will outcompete the coral.
And this is obviously different algae to the algae we talk about that's inside the tissue.
Yeah, so this is macroalgae. So this is like your turf algae that just covers substrate, or you have much thicker algae, like there's an algae called Halimeda, which has also got like calcium carbonate in it. So those sort of thicker algae that can be eaten by grazers like parrotfish, removing those. So a simple thing you could do is, if you have a reef where a lot of reef fish are massively overfished, simply protecting your parrotfish might help coral recovery, because their populations will rebound, they'll start grazing more, and they'll create space for corals to settle and grow again. Also removing coral predators, so big ones that's happening in Australia and stuff is the crown of thorns starfish, is a really prevalent coral predator, and it can decimate coral reefs if there's an outbreak of them. So controlling those populations, those are sort of the ways in which you can help a reef restore, is like not just working with the coral itself, but working with the entire ecosystem.
And is the aim, is the hope to essentially be able to scale this up beyond just reefs in the Maldives? Like what are some of the main approaches to restoring reefs not just in the Maldives, but elsewhere? Like, what needs to be done to kind of secure the future of coral reefs?
Yeah, this is definitely something that we'd like to, expand and be something a lot more global. It's not just, specifically related to the Maldives. It's where it all started. But yeah, it can definitely be applied elsewhere, and it should be applied elsewhere. We should be looking at, the bigger picture and how we can help a reef to recover. That's not just necessarily adding coral fragments to a reef. And that is still, a very useful technique. And if your main goal is to just increase coral cover, then that's still going to be the best way to do that. So yeah, I think it depends on the goals that you have for restoration and the goals that you have for coral reef regeneration and what you want to achieve. There are some reefs where it's quite obvious what the problem is. And so if you can mitigate against that problem, if there's sedimentation or if you have a sewage outflow pipe, you can redirect those and you can manage those systems, more locally. And that can really help improve the chances of a reef recovering.
Yeah, I think it really is that. It's not one size fits all, right? Some reefs need different projects or different treatments. Some species of coral need different treatment as well. It's a really varied. It's not as simple as, well, why don't we all do this? It is very much what is needed in that reef, in that region. What are the biggest threats to try and give the corals as big a break as possible, because we've still got the overriding threat that on a individual level you can't change, which is of course the increasing temperatures.
Yeah, if you can mitigate a lot of your local pressures, it's going to give corals a stronger chance at withstanding some of the more global ones, like increases in temperature. So it is really important. And I think something that's really important about this project as well, and about any restoration project, is getting your local community involved and having them really be stewards of the ocean and their reefs. They know it more than anyone else. And so they should be really involved in helping protect it and kind of lead these projects as well.
That's a brilliant point. It's something that is forgotten too often in coral restoration projects, is to get the local communities involved, engaged, make them stakeholders, and hopefully have them being the ones that have the agency to be able to do it. So yeah, really, really brilliant. Before we wrap up then, Rhi, I want to ask you sort of, what is one of the most sort of memorable moments for you with coral, like as on a coral reef? What is something that really sort of blew your mind, and just a beautiful story to finish this episode off?
So many, it's really hard to pick one. I really do think some of the reefs that I've been going on in Lamu were pretty incredible, diving on those and then turning around and there being, a small school of devil rays. That was pretty incredible. There's also this really fantastic reef on Magudu Island in Vanuatu in Maldives. And that reef was just one of the most spectacular reefs I'd ever seen. It was right off a local island. It was fairly shallow water, and this top of this reef was just hundreds of table acroporas, these massive table corals that were just like longer than I am in some places, and it was just stunning, and the marine life on them was incredible, and yeah, really, really nice. And unfortunately, a lot of those tables ended up dying in the 2024 bleaching event, so not quite so beautiful. But I think what is reassuring is swimming on a lot of these reefs and then seeing how many recruits there are. So it's showing that these coral reefs are recovering and saying, okay, yeah, they have died off, but but seeing it rebuild itself is also really special and hopeful.
Yeah, Rhea, I think that's a great story. And I think really nice to end on a kind of hopeful note, just to let everyone know that, although we are seeing all this news and all these photos and videos of mass bleaching events, that there is still hope, and there are still a lot of amazing people like yourself that are working to protect and restore these reefs and help them become more resilient for future bleaching events. So yeah, no, I think that's all the time we have. We just really want to thank you for joining us on this podcast, Rhi. It was really, really insightful. And I hope that everyone listening got to learn a little bit more about coral reefs.
Thank you so much for having me.
Yeah, of course.
Thank you so much, Rhi. It was brilliant.